Okay guys, so the main purpose of this video is to give you a structure for any question on inclined planes, which will definitely come up in the exams. As you can see, it's a very wordy question, but you need to be able to extract key pieces of information. My advice is drawing the diagram again, because if you have an inclined plane question in this form, the way in which I would want to handle it is actually by drawing a diagram in such a way where you can put all of the information from the question in the diagram. So here I've got a particle P, okay, and I'm going to label that here for you. And then obviously you've also got a particle Q, which is going to be here. Nice large boxes, just so you that all of the information can be placed in there. Particles P and Q have a mass of 0.3 kg and mkg respectively. So for part P, particle P, 0.3 kg, and particle Q, mkg. As I'm going to read the question, I'm going to extract all the information I need to answer the question, line by line. So I don't need to read the question again. The particles are attached to the ends of a light inextensible string. The string passes over a small smooth pulley which is fixed at the top of a fixed rough plane. My advice is to write down whether the plane is rough or smooth here. Okay, so I've extracted that information out as well. You've been told that the string is light and inextensible. That means that there's a tension force acting here, and the tensions for both particles are the same. And in addition, you know that the acceleration for both particles will be the same. You don't know which way this system is moving at the moment, so let's read it further. The plane is inclined to the horizontal at angle A, where tan alpha is 3/4. Now, as soon as you see this in a question, my advice is draw a triangle, okay? And you've got alpha, opposite, which is 3, adjacent is 4. You should know that a Pythagorean triple will give you 3, 4, 5. And now I can work out, you've been given that tan alpha is 3/4. And just for students who have forgotten, I'm just using SOHCAHTOA, and you know now that sine alpha is going to be opposite over hypotenuse, which is 3/5, and cos alpha is going to be adjacent over hypotenuse. So you should write that down straight away for any question. The coefficient of friction between P and the plane is 1/2. So at this stage, what I would be looking for is to write down that information. And you could potentially write down the information straight in the diagram, because I know that there will be friction acting against the movement of this pulley system. I still don't know which direction the pulley system is moving, so I need to read ahead. So let me just write this down as F max equals mu r, and F max, the coefficient of friction, mu, is 1/2. So I will use this information at a later point, but I've written it down. So let's carry on reading. The particle P is held at rest on the inclined plane, and the particle P hangs freely below the pulley with the string taut. They've given you the diagram. The system is released from rest, and Q accelerates vertically downwards at 1.4 meters per second squared. So this is the information that I needed in order to add onto my diagram. So I've been told that Q is accelerating downwards. So let's put that in. And many students do not write this arrow in, and you need to make sure that you're drawing a double arrow for acceleration and write down that it's 1.4. And obviously, as the string is taut and it's light and inextensible, there's acceleration going up for particle P up the plane, and A is going to be the same, which is 1.4. And now I've got all the information that I need. I don't need to read any of this question now. I've taken everything that I needed and required onto my diagram. I just need to finish it off. Because I've written rough here, even if you were in a situation where you might forget, you've got rough written there already. So you know that as I know where the acceleration is taking my particles, now I'll have a force, a friction force, opposing the movement, and I'm going to write that in as 1/2 r. Okay, so coefficient of friction was given, which is 1/2. So that's me building up the question, and you should be able to do this pretty quickly as you've actually done more exam practice questions. So now what do? You know that this mass and this mass have gravity acting upon them. So let's put that force in. That's going to be mg, okay, coming down. Here you're going to have mg coming down as well, but obviously the m is 0.3, so it's 0.3 g. And I like drawing my arrows nice and large, so you can very clearly see what's happening. in order for me to solve this problem, when I'm working with a particle P, I need to make sure all forces are either parallel to the plane or perpendicular to the plane. This is not parallel or perpendicular to the plane. So I need to force it to become parallel or perpendicular to the plane. The way I do it is by resolving. So I'll go down. Just think of an imaginary y-axis here. I'm not going to draw it in, but that's how you should be thinking of it. And along that imaginary y-axis, I'm going perpendicular to the plane. And then I'm going to go parallel to the plane. And this is your 90 degrees. Put the arrows in. Make sure you put your arrows in. And now I've got this angle, which I believe has been given as alpha. So let's put the angle in. This angle is alpha. And if that's alpha, you should all know by now that this is also going to be alpha. And from there, I can resolve my forces. Hypotenuse is 0.3g. So I've got 0.3g cos alpha and 0.3g sine alpha. So that's now my diagram nearly complete. I've got one force missing, which is the reaction force here, and that's your R. Okay, why? Because obviously P is contacting the inclined plane. So when there's a contact, there needs to be a reaction force on my diagram. And now I believe my diagram is complete. Once you got to this stage, my way of thinking about these questions is just to have a process in your mind. And you can answer any of these questions. Okay, this question, the full question is what, 16 marks? I'm just going to focus on the first two parts, which is 10 marks. So the way I would handle this type of question is, make sure you're writing very, very clearly. For particle, I'm going to start off with particle P. Very, very clear what I'm trying to do. And then I'm going to resolve perpendicular to the plane. Okay, I'm resolving perpendicular to the plane. And all I'm going to do is, for particle P, forces up, perpendicular to the plane, equal forces down. So what does that mean? That means that R, that force going up R, is equal to 0.3g cos alpha. And that's really all I can do at this stage. Now what I'm going to do next, I'll use a different color pen, is for particle P, I'm going to resolve in the direction of acceleration for particle P, which is up the plane. Okay, so that's what I'm going to do. And I'm going to use Newton's second law, which is F equals ma. So the resultant force for this particle with up the plane as positive is T minus 0.3g sine alpha. Okay, and also what's going against this? That's going against it, and also minus half r. Friction is going against it as well, minus half r. And that's equal to the mass, which is 0.3, times by the acceleration, which I've been given in this question, and that's 1.4. Okay, so I've set that equation up for us to sort of work with at a later point. Now my final part is to now think about, okay, I've got equation 1 and equation 2 from particle P. Think about particle Q as well. So for particle Q, I'm going to also resolve in the direction of acceleration. So resolving in the direction of acceleration, which is down, F equals ma. So the resultant force for this is mg positive minus T equals the mass, which is just m in this case, times by acceleration, which is 1.4. So I'm just going to rewrite that for you as 1.4 m is mg minus T. I mean, I would probably write T here because I know I'm going to have to use that at some point and rewrite that as 1.4 m minus 1.4 m. So I know I've got an equation for T. This is what you need to do for every question. I'm not really worried about whether I'm answering part A or part B first. I personally don't worry about that. I know I'm going to have to use all of these equations of motion at some point in the question. And that's the question set up. And that's all I really want to share with you. In terms of solving this problem, once you've set it up, you should all be able to solve it by now. That's the simultaneous equations, you know. But the problem is that if you can't set up the question, then you're going to get 0 marks. And I don't want anyone to get 0 marks. So I'm going to make more videos just showing you how is the question set up. Once you've got the question set up, I will leave the rest for you. Did that even record?